Another example, the region bounded by x equals 0, y equals square root x, and y equals 2 about the line x equals 4. Put them all together. At 4, y will be 2. X equals 0 is the y-axis. And the line y equals 2, horizontal line. So the area bounded by this tree graph is shaded. Rotate about the x-axis, x equals 4. So the slice will be perpendicular to the axis of revolution. And this is the point y. Therefore, y will be anywhere between 0 and 2. And the thickness or the width is delta y. Which is dy. Next, look at the outer and inner radius. Measure from the axis of revolution. The outer radius is the longest part measured from the axis of revolution. So this is about with respect to y. So we have to consider the right function minus the left function. And the right function is x equals 4. The left function is x equals 0. Therefore, the outer radius is 4. The inner radius is measured from the axis of revolution to the closure curve. Same idea, the right function minus the left function. So the right function is 4. The left function, which is the graph y equals x squared. No, sorry, y equals square root x. Therefore, x equals y squared is the formula we're going to use. So y equals, the inner radius is 4 minus y squared. Set up the volume, the integral from 0 to 2, which is the low y to the high y, pi times the outer radius squared, or 4 squared, minus the inner radius squared, or 4 minus y squared squared, times the width or the thickness, or dy. Take the pi out, clean up the inner, the integrand, which is 16 minus 8y squared plus y to the 4th. With respect to y, simplify a little bit more of the integrand. We have pi times the integral from 0 to 2, 8y to the 2nd minus y to the 4th. With respect to y, which equals pi, apply the antiderivative rule. We have 8 over 3 times y to the 3rd minus y to the 5th over 5. Evaluate from lower limit y equals 0 to upper limit y equals 2. Replace the values. 8 over 3 times 2 to the 3rd power minus 2 to the 5th over 5 minus 0 minus 0. That will give us the result 224 pi over 15.